Welcome back to day 33 of LeetCode Grind, Solf or Go Home. 30-minute Solf or Go Home. Alright, let's see. Jump game. Okay, jump game 2. Given an array of non-negative integers nums, you are initially positioned at the first index of the array. Each element of the array represents your maximum jump length at that position. Your goal is to reach the last index in the minimum number of steps. You can assume that you can always reach the last index. Okay, so it says your initial position in the first. Each element represents the maximum jump length. Okay, so basically, you want to reach the last index, and then each jump moves you across the indexes. Is that what it means? So each.
Right.
So in the first one, it says you can jump 2. So that means you can jump to either position 1 or position 2.
Mm-hmm.
Okay, I see. Okay, and they want the least amount of jumps to the. Okay, I see. Okay, so okay. So I think you probably want some kind of DP.
Okay.
Cause then
How are you thinking?
because basically you kind of want to take your first jump at the maximum, but you also want to know if you don't take the maximum, if you get a better jump. So maybe kind of like you kind of want to like pop your previous jump and check to see if the other jump is better.
Okay. That's okay. I think you're on the right track, but can you be more specific about what you mean?
Yeah, so maybe like okay, so you take your first jump as the maximum. So so your first jump you go to your maximum distance, and then actually if you do the DP array, I think at each index you can store the maximum index it can go to at each index, and then okay,
Okay.
wait, but that doesn't help us calculate the minimum jumps.
Okay. So
Okay,
why don't you
okay,
keep it all?
maybe instead each index you store the minimum jumps to each index uh, of the.
Uh, well, okay. So let me ask you this: do you need to know every index?
No, you don't need the last index.
Kind of.
Well, that's the answer, the output. But then you're saying like, do I need all the indexes to calculate the last
All right.
index
So
essentially?
let's say you start with the first guy. You can jump to.
Mm-hmm.
So what is the best place to go to?
Well,
Let's say you
it's
don't know how long the array is.
you don't know how long
So you're
that.
you're choosing between three and one, right?
Yeah,
Three in the next position and one in the one position after that.
I think you always want the bigger number because it allows you to have better opportunities.
Uh, kind of, but not.
Okay. Sorry. It's bigger if it also gives you a better jump than the second one. So let's say
Right.
because then it's
So
three
now,
versus
now,
one,
now
right?
you're
Because you lose one index, but you also gain 2 jump power. So as long as you're
right.
gaining stuff, it's worth it.
Yes. So it is exactly as you say. So you want to be a little bit greedy with maximizing how far you can go.
Okay. So basically, what you're saying is, you given your starting index, you
Mhm.
scan all the possible jumps and you grab the maximum one of those, and then that's where you land.
Well, not just the jumps. So you can go anywhere from for okay. If your current location is two, then you can go to the next two positions, and for each of these two positions, you're adding, I guess, the value at that position to the farthest you can go.
Yes.
And if it gets you further, then you want that one.
Mm-hmm.
If it doesn't get you further, then
Then you don't want to jump to that position.
exactly.
Yeah. So basically, whatever position you're at, you're scanning everything that it can go to, and then you want to land at the maximum possible one.
Uh, Right. I think you have the idea, but how I guess how would it work if it was, let's say, 2 3 2 1 4.
Okay. 2 3 2 1 4. Okay. So you start at position 0. You can maximum jump 2. So the 3 and the 2 have equivalent power.
Right.
So I think
What do you do in that case?
I think you would take the maximum index in that case. I don't think it matters actually, but I think yeah, it just depends on how you want to handle your algorithm.
Well, I mean,
Oh no! It does matter. It does matter. So you want to take the maximum in case that is the exit and you're done.
uh, well, that's not strictly true, but um,
No,
I
because
think in general you want to pick the biggest index.
yeah, that's
But
what I'm saying.
so,
That's
so
what I
why?
just said. Maximum index in
But it's
case.
not because it's the exit.
Oh, okay. Well, why do you want to take maximum index then?
Because if you get to that index at a later state, then you are not wasting steps getting there, I guess.
I see. No, because then if you have the same jumping power, you're gonna take the same amount of moves to get there anyway, right?
Okay, I mean that's true. Um, Actually, yeah, I need to think about that.
Well, also okay, I think I think also you take the maximum index also is because you scan less. You have less to deal with. Because then if you take the smaller index, you still have to scan ahead again. See, it's doing more operations, right? If you take the maximum index, you're cutting down operations. So actually, that is a slightly more optimized.
I cannot convince myself why you wouldn't, why they're not equal actually. So
They might be equal. It's just it seems like it's probably better to take the maximum because you might have less operations to deal with. So
hmm,
like it's just slightly more optimized, I guess. I don't know. I think either way it's almost the same. I don't see why the less or the
okay,
max.
but then let's ignore that case. But basically, so you want the steps taken and the new steps added to be maximum, right?
Yes. So yeah, so given your current position, you look ahead however many you can, and then you just grab the maximum gains basically, and
Hmm.
also I guess tiebreaker just take maximum index just in case.
Okay.
Okay, and then you just do that till you exit, right? So it's not even DP. It's just looping.
Right. But um, okay, yeah, sure.
Yeah, and it would be less than O of n because you're skipping indexes, right? I guess worst case is O of n, because then you could literally it could just be all ones. Yeah,
Right.
yeah, and I think that's fine. O of n is probably fine. Okay. So the algorithm basically is you need a count to see how many steps you're taking, and then you just loop through. So instead of looping through, because I'm going to be jumping indexes, I'm going to just use while. Okay, so index equals 0, while index is less than len nums. Okay, and then we want to scan ahead. So it would be scan ahead equals nums index for I in range scan ahead. We want to check to see which one is the best one. So it'd be like a max jump equals guess set it outside. Max jump equals nums index, and then yeah. And nums of I. Wait, is that it? Okay. I in range. No, the I in range doesn't do the indexes. I in range would just be 0 and 1. So that's wrong. I need to do no, it should be I plus index. Okay, because if index is 0 and then I'm checking range of 0. Okay, well actually no, I in range scan ahead would start at 0, so 0 plus 0 is still 0. So I don't want this. I want I plus 1, I think. How do I make it start at 1?
No.
How do I make it start at 1? Is it the 1 comma?
The range of 1 to scan ahead plus 1.
Okay, there we go. Yeah, okay, that makes sense. Okay, yeah, so that would give me the index. Okay, so I plus index should get me the nums that I want. Okay, I need to make sure it's also not out of bounds. So if
if it's out of bounds, then you're done.
Yeah. So no. If it's out of bounds,
then you for sure reach the end.
Yes, but you still have to calculate that last jump. It's only done if you are specifically on the last one. Because otherwise you might scan ahead still, but then you notice that you can't exit with one more jump.
If you're on the last one, you're done.
Yeah, if you're on the last one, you're done. But then I'm saying, let's say you're on the second to last one, and you have a jump. So if you're scanning, you might scan out of bounds. I'm just saying, like, in that case, you still have to add one more jump. So it's if your current jump, if okay, wait, no, this shit, wait, yeah, this index would exit before that. So I think it's just return count, because after you exit the loop, that's fine. But then in this case, I need to handle the out of bounds. So if I plus 1, no, I plus index is greater than nums, len nums, return count plus 1. That should be fine. Else, then I do the rest of this shit. Okay, so max jump, set max jump. Okay, that's fine. And then given the max jump, I will jump over. Okay, wait. Given the max jump, I set the new index equal to. Wait a minute. I need to set the new index too. So, okay. So I did the scan, and then I calculated max jump, but I did not set the index. So it'll be index equals, wait a minute, max jump. Okay, this is not good. This needs to be done outside. Okay, that's fine. And then I want to. Yeah, no problem. Max jump is 0 here, and then after this algorithm runs, it's gonna put in. Oh wait, no, it should be max of max jump. Nums of I.
Nope.
Oh, it's time travel.
Yeah, we'll go back.
No. Wait, are you doing puzzles?
Not quite. I'll be done in like 5 minutes.
Oh, yeah, so, oh, okay.
Okay, this should.
Hello.
Yeah, what's up? This shouldn't be max of max. I need to subtract. Okay, so it should be the power of gain. Okay, so shit. I need to calculate the index I'm in and also the jump gain. So okay, so I need nums of I plus index minus index. Cause then that what's up?
Are you minusing index?
To calculate how much gain you have, because if you just take the max number, it's not necessarily correct, right? Because then if you it could be like
Sure, but nums of I plus index. Why are you subtracting index? I'm confused.
so yeah, like in the example, let's say it was 2, I don't know, maybe like,
Oh, wait, hang on. Are you calculating the position you'll end up in, or are you calculating how many steps you can take?
well, I'm calculating how many steps I can take, but I also need to calculate the position I end up in.
Well, I mean, how many steps you can take is plus your current index is the position you'll end up in. Okay. So you just have to calculate one of them.
Yeah, I'm setting index to max jump probably, but yeah. Yeah, that's fine. Okay, wait a minute. So the example is if I had a 2 and then a 2 and then let's say it was 4. Does that matter? Okay, so let's say, yeah, you can take the 4 or 2. No, this example is bad. It should be 3. Okay. So in this example 2, 3, 4, 1, 5, right? The 4 is bigger, right? But then you want the 3. Oh, wait, no. I'm mixing this. It should be 4 and 3. My bad. Okay. In the 2, 4, 3, 1, 5 example, the 4 is bigger, but you no shit.
You can take either.
You can take either. Yeah, my bad. Ah, shit. I'm confusing myself here. I need to make an example that works for this case. Why? What was it? Okay, let's put this. Alright, so I guess I move this over. Maybe, yeah. 3, 2. Let's put this as 3. Okay, it was 3, 4, 2, 3, 5, right? So the 4 is bigger, but you want the 3 because the 3 will allow you to get further. Because then 4, you can check 4, you can jump 4 ahead, right? But the 3, you're in a better position already, and you can jump 3 ahead. So then the gain on that is a lot better than the 4. Which is why I'm trying to do nums of I plus index minus the index, so you can calculate the maximum gains you get. But then, yeah, so the maximum gains I get doesn't necessarily calculate my correct index. So I need to also track the index that I'm taking. So I can set the index. So in this case, shit, I need the index that I'm selecting. So in this I plus range, okay, so I need something else. I need if max jump, if nums I plus index and minus index is greater than max jump, then I take the okay, so it'll be index.
I don't really understand why you're minusing index.
Cause did you see the example 34235?
Okay.
All right, what do you take in that position?
You take position 3.
Exactly. So if you're taking that position, right? How do you know to take that? So, like, if the algorithms
Because 3 plus 3 is bigger than 4 plus 1 is bigger than 2 plus 2.
exactly, that's why I'm adding the index.
So why are you subtracting the index? So max jump would be 6, right?
Mm-hmm. Max jump is 6.
So that's 3 plus 3.
Yeah. Oh yeah, it should be the index plus that. Okay, yeah, it should be plus index. Okay, in any case, I can't use this code anyway. I have to do this. Okay, so if the nums of I plus index is greater than max jump, I said max jump equals to nums I plus index, and I set index jump equals index. Wait, what? No. I set index jump to index plus max jump. Wait, no, that's wrong too.
No. So index jump is like I, right?
Kind of. I is the stuff you're scanning. Yeah, I guess that's correct. Yeah, I guess it would be I. Okay.
And then
I need to oh shit. And then yeah, index would equal index jump. Wait, no, not index jump. Index jump. Wait. Max jump already added the index to it. So couldn't I just set it to max jump?
no, because you might reach the max jump before. Wait, what? Oh, it's index plus equals max jump, right? No, sorry, index plus equals index jump.
You're saying for this line? For line 22?
Right.
Okay, but wait. Then when do you do max jump shit?
You don't care about it.
Well, I don't care about that.
Max jump should be set to 0 every time, and then you figure it out every time. But it shouldn't be outside.
Wait, what? No. Wait. Oh, okay,
We're
wait.
only calculating it for the local.
We're using max jump only to grab the index that you want to jump to, right?
A given jump, right?
Oh, we're only using it to calculate which index we want to land at, right?
Exactly.
Oh, so it's useless. Okay. I mean, it's not useless, but like it's not. We don't use the variable for anything else.
Well, you use it to pick the maximum. You're guaranteed to have a max jump, so index jump doesn't really have to be defined on line 12.
True. Okay. Wait, if you don't define it there, can it access it? It's
Yeah,
but
if the if runs, then you have it.
Yeah, but then that if is in a
They're saying they give you valid input. They're not going to give you 0, 0, 0, 0, 0.
yeah, that if is in a for loop though. I guess Python has what is it, variable hoisting or some shit like that. You can access a declaration of it within something, another
No,
context?
no. If they're giving you valid input, then index jump will be defined. If they're
Yeah,
not giving you
yeah,
valid
that's what I'm
input,
saying.
then
Like,
it will throw you away.
it's gonna be, it's not, it's defined, but it's inside a different context than this. So technically, in like
It's the same, it's
Java,
the same concept.
in Java
So
it wouldn't work.
basically, if you gave it broken input, index jump will not exist,
No, I'm
and
saying
then
in
it
Java
will.
code this wouldn't work, but this works in JavaScript. So is Python similar to JavaScript then? I guess
I have
maybe.
no idea. Probably.
Yeah, it's this code does not work in Java. Because then you didn't declare the variable, but I guess in Python it doesn't. It lets you declare it like out of scope, kind of. Okay, that's fine. So if it is greater than max jump, I set max jump, and then I set index to the new index, and then we just loop through all of it in the scan.
When does count increase?
Yeah, its count doesn't increase right now. Count should increase every time I jump. So every time I set the new index, I should increment count. And then and then each index increases. We'll go restart the loop, and then it gets the new scan ahead, resets max jump, and then does the scan ahead again. Yeah, that should be okay.
Line 15 looks a little sketch. What is your target index?
What do you mean?
In the problem, what do you want to reach?
The end.
Right, and what index is the end?
Len of nums minus 1.
Correct.
Okay.
No.
Outside.
And what if it's equal to?
If you're equal, you're also done.
Right.
But if you're equal, you don't want to return count plus 1. You want to return count.
Yeah, you do.
What do you mean? If you're equal, you don't need a jump. You're equal, you're good. Oh, this is I plus index. This is not. Okay, I see. Yeah, okay. I plus index. Yeah, okay. I plus index. Scan.
Okay.
Wait. For I in range of scan ahead. If I plus index. So in what? Wait, I does not work. What the hell is I? I is in the range of that. Okay. Oh, it's okay. I see. It's because you don't want it to be out of bounds. That's why. So if it's if as long as there is one index. Yeah. So if okay, yeah, if you're scanning ahead and then it's out of bounds, that means you that doesn't guarantee you only need one jump though, does it? Shit. Cause then that's okay, that's weird. Okay, so what if it was 1, 2, 1, 1, 3? Zero, zero. Okay, if this was the case, I need one jump to this one jump to this one, and then this one would scan out of bounds, but then 3 can't jump outside. What if it wasn't 3? What if it was 2? I don't know. Wait. Is there ever a case where it wouldn't? No. Okay, so if there's 2 here, and you scan outside of bounds, 2 can scan out of bounds. But 2 can also jump. Yeah. As long as you can scan out of bounds, you're guaranteed.
You can scan out of bounds, you can reach the end.
Yeah, okay, yeah. Okay.
That's guaranteed.
Alright, then that's fine. Yeah, I think, well, this logic should work then. Max jump, set max jump when it's max, yeah, and then index is this. Okay, that's fine. Alright, I guess it works. Nope. Yeah, this is what I was talking about, Alan. Local variable reference before assignment. So I guess the 0 is invalid input. Yeah, okay. 0 means you can't jump anywhere. Oh, index is less.
No, I get. Okay, fine. Yeah, there's an index jump to 0.
Yeah.
But you still get the wrong number because, yeah, now it loops forever.
Yo. So the issue with that is because.
First of all, if it's size 1, you know you're done.
I mean, yeah. I guess I could just check for that. Wait, but then, oh, that means you're on the exit ready. So yeah, you're done. Okay. If when okay. What is this case? 1 2 1 1 1. Okay, so you start here, take 2, land here. You got one more. So it's 1 jump, 2 jump, 3 jump. Why does my algorithm take 4 jumps?
Oh, I see the problem. Max jump should not be plus IDX.
Wait, this one shouldn't be?
21.
Yeah, why not?
Where is I?
What do you mean, where is I? What's up? What do you say?
IDX doesn't change,
Okay, that's fine.
but I changes. So why are we adding IDX?
Oh, I see. Yeah, so basically it's the max jump is always the wait, no, it should be IDX.
That part is fine.
It shouldn't
The
be
second part is
IDX. Why is it not IDX?
Because IDX doesn't change.
That's fine.
Can you analyze 3, 4, 2, 3, 5?
3 4 2
What is max jump? What is max jump in 3, 4, 2, 3, 5?
Max jump is 6.
Why is it 6?
3 plus 3.
Why is it not 7? Because 4 plus 3 is even higher.
Yeah, you're right. Why is it not? Wait, 4 plus 3? You can't get 4 plus 3. What are you talking about?
Yeah, you can, because if I is 0, oh, sorry, if I is 1,
Yeah.
and I plus IDX is nums of I plus IDX is 4,
Yeah.
and IDX is 3.
IDX isn't 3 though. IDX is 0.
Oh, okay, sure, fine. Then okay, then you don't even get 6. You'll get 4, 2, or 3. That's it.
Or true. Is that true? That is true. 4, 2, or 3 is because, oh yeah, because index is always 0. So you're only adding 0 to it. Okay. So instead of that, we want to add the, oh shit. We want to add its current index to it. So its current index is I.
What is current index?
Is I.
I mean, that's correct, but I don't know if you understand why it's correct.
No, because you need to add its current index to get the maximum jump, right? So 4 plus its index 1 is 5, 2 plus index 2 is 4, and 3 plus index 3 is 6.
Correct. So which is why you cannot add IDX.
Yeah, because
That
IDX is 0 all the time until, well, not all the time, but like until it's updated. Okay, that did not work. Max jump. Oh, this one has to be I also. Alright. Okay, cool.
Okay, nice. Just be careful when you're using multiple indices.
Yeah, I didn't realize that was the wrong thing. Alright, thanks.
Alright.
Alright, bye.